So hi and hello. Welcome to our channel named Algo Exploration. My name is Samir. Now in today's lecture we are going to find power of 2. That means 2 raised to n. So let's take one example. So let's say if we have 2 raised to the power 1, we obviously know the answer would be 2. 2 raised to the power 5, the answer will be 32. 2 raised to the power 10, answer would be 1024. Okay, so here we are going to design an algorithm. Okay, so the value of n can be anything and we need to find the answer. Okay, so since we are actually learning the recursive technique, okay, but as I said earlier, every recursive program can be transformed into iterative and vice versa. Okay, so first let's see that how we can design an algorithm that uses iterative approach. Okay, here the approach will be very simple. See, let's say if you want to find the power of 5, okay, what we have to do, we have to simply multiply the 2 5 times. Okay, so using the simple for loop, we will be running that for loop for n time. So initially the answer would be 1. Why 1? Let's say if anyone put the value of n as 0, then 2 raised to 0 will be always 1, right? So due to that reason I have put answer as 1. Now using the for loop where I will be coming from 1 and it will be gone till less than equals to n I plus plus. Now answer is equals to answer into 2. That's it. And at last simply return the answer. Okay, so this was the simple iterative approach. If you talk about the time complexity, it will be simply order of n. Why? Because the for loop is running for n time. Okay, and if you talk about the space complexity, it will be constant because we didn't take any extra space. So the iterative approach was very simple. Now let's try to design a recursive approach. Okay, now if you watch my previous recursion video, you know that recursion is nothing but solving the sub problem, and the answer of the sub problem will be accumulated to find the original answer, right? So similarly, using this idea, let's say that we want to find the answer of 2 raised to the power 8. Now what is 2 raised to the power 8? It is nothing but 2 raised to the power 4 multiplied with 2 raised to the power 4. So 16 into 16 leads to 256. That is nothing but 2 raised to the power 8. So using this idea only, let's see that if we have 2 raised to the power 8, what I will be doing, I will be dividing this 8 by 2. So we will be getting 2 raised to the power 4, and here also 2 raised to the power 4, and whatever answer I will be getting for 2 raised to the power 4 and this 2 raised to the power 4, I will be simply multiplying it and returning it to 2 raised to the power 8. Similarly, for 2 raised to the power 4, this will be 2 to the power 2 and 2 to the power 2. Same goes for this. And for 2 to the power 2, it will be 1 by 2. That will be 1. We are taking the integer value. Okay, okay, so as I said that in the previous lecture, if you are designing the recursive approach, okay, there has to be a base condition or the anchor condition, otherwise it will leads to infinity and results to stack overflow. Okay, so here if the n is 1, okay, so we can simply return 2, or else if the n is 0, we can simply return 1. Okay, so here we can see that the value of n is 1. Okay, so in this case we will be simply returning 2. So the value of this will be 2, this will be 2, and so on. Okay, and while returning we need to multiply it. So 2 into 2, the value of this will be 4, this will be 4, this will be 4, and this also will be 4. Okay, again while returning we need to multiply this 4 and this 4, so this will be 16, this will be also 16, and again this will be 16 into 16 will be 256. Okay, so in this way will be going to design an algorithm. Okay, so let's name the function as power. So power, I will be passing simply n. Okay, because 2 is already defined. If my value of n is 1, here in this case I will be returning 2. Okay, if value of n is 0, I will be returning 1. Now here else return power n by 2 into power n by 2. That's it. And this is the recursive program. Okay, but here there is a glitch. That means let's say if the value of n is 5, value of n is 5, so 2 raised to the power 5, this will be going to divide 5 by 2, that means 2, taking only the integer value, here also 5 by 2, 5 by 2, that means 2. This will be 2 raised to the power 1, 2 raised to the power 1, 2 raised to the power 1, and again 2 raised to the power 1. Okay, this will be 2, 2, 2, and here also 2. This will be 4, this will be 4. Okay, we are not calculating in our mind. Okay, we are actually taking this value, 2 into 2, that will be 4, 2 into 2, that will be 4. Okay, and 4 into 4, this will be 16. Okay, but we know that 2 raised to the 5 is 32, not 16. Okay, so if the value of n is odd, we need to simply multiply this 16, let's say, okay, into 2. Okay, if the value of n is odd, whatever answer we are getting, we need to multiply it with 2. That's it. Okay, so the revised algorithm will be, I will be taking this only and I will be modifying it. Observe here. See, here in this else case, if n modulus 2 is equals to 0, that means it is even. Okay, so here in this case we don't have to do anything, simply return power n by 2 multiplied with power n by 2, right? Else, that means if the value of n is odd, here also we have to return power n by 2 multiply with power n by 2. Now here we also need to multiply it with 2 again, then only we will be getting the answer if the value of n is odd. I hope you got this, and that's it. This will be the R code for finding the power of 2 using recursion. But here we can see that, let's say if my value of n is 5, if my value of n is 5, okay, 2 to the power 5, then this is getting divided 2 to the power 2 and then 2 to the power 2, right? Again after that we need to multiply it, so 2 to the power 1, 2 to the power 1, here also 2 to the power 1, 2 to the power 1. Okay, we can see that here we are actually finding the value of 2 to the power 1 4 times. Okay, then finding the value of 2 to the power 2 two times, okay, and so on. Okay, so let's imagine that if the value of n is too big, so we are actually doing a repetitive task again and again. Okay, so to eliminate that, okay, so what we can do, if you observe this only, see, for finding the value of 2 to the power 5, we are actually finding the value of 2 to the power 2 and then 2 to the power 2. Here we can see that both are equal, right? So instead of finding 2 to the power 2 again, okay, we can just simply put this value in an answer variable, okay, and while returning it, simply return answer into answer. Okay, basically we are doing the same task, but we are not actually calling the another function. We are simply storing that value, okay, and then returning it. While returning it, we are simply returning it as answer into answer. Okay, so here is what I'm trying to say. See, power n, if n is equals to 1, return 2. Okay, if n is equals to 0, here in this case return 1. Now else, here in this case, first of all, I will be finding the answer as power answer by 2, sorry, power n by 2. Okay, now I'm going to check if n modulus 2 n modulus 2 is equals to 0. If that means if the n is even, so return power, sorry, not read power answer into answer. Else, that means if the value of n is odd, so return answer into answer into 2. That's it. I hope you got this now. I'll be putting this code side by side so that you can compare. So this is the optimized one, and this is the previous one. You can see the difference. See, here we are actually finding the power of n by 2 two times, but here we are simply finding it one time. Okay, so this is a little bit of optimization. If you talk about the time complexity, okay, so this approach is taking order of log n base 2, and this is taking order of n. Okay, so this was it, okay, from my side for finding the power of 2. So that's it from my side. I'll see you in the next video. Till then, keep practicing.